Welcome. Welcome to the Canon Creative Studio at Sundance 2026. So happy to have you here. My name is Cindy Bear, and I actually am the event specialist at Canon Burbank. And really quickly, before we start this great panel, this great discussion, I just wanted to let you know a little bit about Canon Burbank. So if you're in the Los Angeles area, it's a community hub for filmmakers and for photographers, where we do lots of great events like the ones you're going to see here at our activation this week during Sundance. So besides presentations and panels and workshops, we also do screenings for projects that were shot with Canon. And we offer individual camera tests. So if you had equipment that you wanted to come, I can make an appointment for you with a tech specialist, and you could actually test our gear right there at our facility. So be sure to scan the QR code back there if you want to be notified about events as they happen. And or if you want to pitch an event, you can talk to me, and I'm happy to hear about that. So I hope to see you at Canon Burbank. And without further ado, our senior tech specialist, Paul Hawxhurst, is going to give you a wonderful presentation. And take it away, Paul.
Hey. Thank you, Cindy, very much. Hey, everyone. Welcome to Sundance, and welcome to my little tech talk. This is really nice. I feel like this is really intimate. So, my name is Paul Hawxhurst, and I am the senior tech specialist concentrating in cinema for Canon out in New York City. All right. And so basically, my job is to talk to major clients, talk to dealers, talk to DPs, anybody shooting, and train them on the cameras, train them on all this stuff when it comes to our cinema videos line and everything like that. And that's kind of basically what I do. So I just talk about this stuff all day long, man. But this one that I want to do today is about this new thing going on that we just incorporated into our cameras. It's called Open Gate. Now, they didn't give me a panel, so you guys get to be my panel a little bit here, all right? So I'm going to start off and ask the room a question. Has anybody shot video using a camera with open gate recording? One there. Yeah, I know you have. Who did? All right. Wait, hold on. Let me get. Oh, okay, my slide is up. Sweet. All right. Has anybody here shot a still picture using a DSLR or a mirrorless camera? All right. Are you guys? All right. That means that you have also shot Open Gate. All right. The big thing about what Open Gate is that it is using the entire width and the height of the sensor. All right. That's what's so special about this term of Open Gate. And you might be asking, like, what's the big deal about that? Right? Why is that so special? Well, that's why I'm here. I want to take you down a little trip down memory lane into why we got to this point and what's going on, why this is such a unique thing right now. To start, I have to do my due diligence first, so I got to do a little plug here for Canon. We currently have 3 cameras that is capable of open gate recording. All right. Starting off with the Cinemedios C50, which we just released recently, came out at the end of November. The Cinemedios C400, which is kind of right now our flagship product in the cinema line. And then we also just recently released R6 Mark III, which is not part of our Cinemedios line. And I'll talk a little bit about that. But let me start with the C50. So the C50 is capable of doing open gate recording in 2 codecs, in 2 formats, all right? First of all is internal cinema raw light, which is internal raw recording. And the second one is XF-HEVCS. All right, so this is one of the non-raw codecs and non-raw recording options that we have in our cameras. All right, and you see that there's a little bit differing on the resolution here. The resolution for cinema raw light is 6960 by 4640. All right, that's full resolution. It dips down a little bit when you go into the non-raw format, and so it's 6912 by 4608. It's not a huge difference, but it's something to be aware of. And it's capable of basically 1 to 30 frames per second while in this open gate format. All right. Now, another thing to note is that when you go into the camera, right, and you're trying to find this open gate mode, well, we call it something different. We call it full frame 3 to 2, all right? What is going on there? I'll explain it coming up in the presentation. All right, moving on to the C400. The C400 did not originally ship with an open gate format, all right? We just put that in via a firmware, just recently, actually in middle of December. So now that that's in there, it has a different resolution because it has a different sensor in it than the C50. So it's only available in Cinema Raw internal recording, and it's 6,000 by 4,000 is the resolution there. And it's available in frame rates of 2398 or 2398, 24, 25, and 29.97. So you don't get the off speeds like you do with the C50 on that board. Also, full frame 3.2. It's not called open gating the camera. Right? The R6 Mark III is a little different, right? This is not one of our cinema cameras. This is one of our hybrid mirrorless cameras. Right? But in the movie mode of that, it is also capable of recording in 6960 by 4640 in the what's called camera raw. It's a little bit different than our cinema side. But it also has the same HEVC-S codec that our cinema cameras does as well. And you might be seeing, looking at those resolutions, being like, oh, that matches with the C50, right? What's going on there? I think they use the same sensor in both cameras, so that's kind of what's going on there. However, on the R6, you don't get the same breadth of off speeds. You don't get that frame rate differential that you do on the C50. So you're limited to 2398, 2425, and 2997. Now, funny enough, on the R6 Mark III, when you go into the menu to find it, they do call it open gate there. What's going on? Why is it full frame 3.2? Why is it open gate? And what's the deal with being able to record the full height of the sensor? Why is that so special? In order to do that, I really want to take you guys back with me, all right? I want to take you back to the film days, all right? So some of you may know this, some of you may be aware of this, and so just hang out, come along with me. Also, I hope you like PowerPoint because that's how we're rocking today. Yeah, PowerPoint. Woo, yeah. Yeah, no video here. Thank you. All right, so in order to really understand open gate and its origins, we need to understand both film capture and film delivery formats and standards. All right. I also hope you like talking about aspect ratios as well, because there's going to be a lot of aspect ratio talk in this presentation. And really, the origin of open gate comes from this kind of disgusting marriage of both capture and delivery formats and aspect ratios. All right, so I just wanted to establish kind of a baseline nomenclature of what we're talking about here before we get into it. So, in film, there are a ton of standards when it comes to film capture. All right, there's a lot over the last 100 or something years of film capture. There's been quite a few. However, we can really kind of focus in on a couple main ones. All right, and that's what I did here. So, first I want to talk about is standard 16 millimeter and super 16 millimeter. All right, so standard 16 millimeter was 16 millimeter film, but the aspect ratio of the frame that it captured was a 1:33 to 1 aspect ratio. Now, down the line, they discovered, hey, we can make film in super 16 format and only need one side of the perforations of the film. We don't need to have both sides perforations. So they got rid of one side of the perforations of the film, and they extended the frame all the way out to the edge of the thing, and that is super 16 millimeter, and that's the format known as super 16 millimeter, right? And when they did that, they extended the aspect ratio of it out to 1:66 to 1. So now we're getting a little bit more rectangular. Now we're getting a little bit longer, not as squat as before. Kind of moving on from that, the main really film motion picture format I want to talk about is 35 millimeter, right?
And again, there's a lot of different formats here that you can talk about on 35. I mean, I could probably spend the next hour just talking about this slide. I will try not to. But when it came down to it, finally, everything settled down. The main format of 35mm motion picture film was a 4 perforation frame, meaning that the frame size took up 4 perforations of film. And it was a final aspect ratio of 1:33 to 1. Right, so that matches the standard 16 aspect ratio, right? So rectangular, but not super rectangular, right? Now there's also other options as well. You can put what's called different movements into film cameras, and you can change the amount of pull down between each frame. And so to do that, people have been doing that before, where they will put what's called a 3-perf movement into their camera. And so now instead of pulling down 4 perforations, it's only pulling down 3. And that's changing the aspect ratio of that frame. So now when I have a 3-perf format film camera, it's now a 1:66 to 1 aspect ratio is my final frame there. All right, there's also a 2-perf format movement. And that actually makes it a very wide aspect ratio. That makes it a 2.39 to 1 aspect ratio. So very, very wide, but not very tall, right? You're losing a lot. It's basically being the same as if I shot that 4 perforation frame and then I cropped it down to that's kind of the same. But why would I do that? Why would I get rid of all that information in film? Well, because it's film, because it's a depletable commodity, right? I have a limited amount of film running through my camera. My magazines come in 400, 4,000 foot loads. And so in order to get more running time on my film, that's why they invented these different movements to make the frame size smaller. And I can drastically increase the amount of running time that I get out of each magazine for it. The final film capture format I wanted to talk about is called VistaVision. So VistaVision is kind of making a comeback these days, all right? And something that you may be hearing a little bit about, recently, but it actually came out in the 50s, right? And there was quite a few, like a lot of the Irving Berlin musicals, like Holiday Inn, were shot in VistaVision and so like that. But then it kind of disappeared as an origination format. It was used a lot for special effects, for background plates, for any kind of those things like that. But the main format for most movies and most high-end television shows was always that Super 35mm 1:3 to 1 4-perf frame. So that was kind of the main format for, say, like 99% of the movies and things that we'd be seeing. Now, when we got to the theater, a whole nother set of things going on here, a whole set of standards. So now we take the film, we've captured the film, we have these aspect ratios on film, but now we need to project it onto a screen, right? So now is an interplay between the capture and the actual projection. And in order for movie theaters to do that, they have to run the film through the projector, but they also need to put a corresponding lens on the projector, which then determines the actual size of the projection onto the screen, all right? And while it's capable to have output any aspect ratio you want, most theaters are like, no, I don't want to go wild having to swap out lenses on my projector to change the size of my screen by moving curtains in and out and stuff like that. So they tried to really nail down set standards for film projection, right? And it kind of came down to what I call 4 main standards there. 1:3 to 1, well, that's easy, right? That's kind of a simple transfer there. In Europe, 1:66 to 1, it was a very, very popular aspect ratio for projection. Actually, one of the most popular, more popular than it definitely was in America. You did not see a lot of 1:66 to 1 aspect ratio projection in America at all. But in Europe, it was all over the place. Just a quick side note, one of my favorite things is the movie RoboCop. The actual true aspect ratio of RoboCop is 1:66 to 1. So that's the way it was always intended to be shown. In America, 1.85 to 1 aspect ratio for projection was our go-to. That was what the vast majority of movies would first project out. When you went to go to the movie theater and it wasn't a super widescreen movie, you would be seeing it typically in a 1.85 to 1 aspect ratio. All right? So that was it. That was the standard there. Now, the other one, I keep saying super wide format. Well, has to do with anamorphic filming. Right? This is a whole thing that we can kind of get into, but 2.39 to 1 was the projection aspect ratio for films that were shot using anamorphic lenses. And this is a process, right? So you shoot with an anamorphic lens and it squeezes the image, right? And at this time on Super 35 millimeter, it's a 2-time squeeze. So it takes the image and it squeezes it in by 2 times to fit it onto the film frame. And when you get there, and it looks really squished, but then when you run it through the projector, you use a lens that unsqueezes it. And so when you put that lens on there and you run that film through the projector, it unsqueezes it out. So all of a sudden, from that 133 to 1 aspect ratio, we have a wide 239 to 1 aspect ratio. We doubled our horizontal, field of view basically on that. And that was the point of anamorphic. And that's why anamorphic was so popular back then for film days, is because you didn't have to sacrifice resolution in order to get that really wide aspect ratio. If I use that 2-perf, that 239 to 1 2-perf film, or if I just crop down to 239 to 1, that's a huge loss of resolution on my film. But using anamorphic lenses, I can use the entire full frame, the full 133 to 1 frame, and have all that resolution and still get the really wide projection. So that was really important. Now, so that very quick rundown of film formats there, and you'll see why I did this when we start going on to it. The next thing I want to talk about is, now we're going to start getting into the really heart here of digital cinema and video. And I honestly, I should have called this slide just video. I was trying to be cheeky, and Dickens is rolling in his grave. So, anyway, I need to talk about video. Let's first talk about television, right? Television was a lot simpler. There were one delivery format for television, and it was a 4:3. And I'm pretty sure everybody here remembers a CRT TV that is a 4:3 television, right? 4:3 is a 133 to 1 aspect ratio. And you see back in the day how easy it was just to take that 16 millimeter 133 to 1 aspect ratio and just transfer it straight to a television that is also the exact same aspect ratio. And that's how it used to be done, because news was shot on film, right? And there used to be soundtracks on the actual film itself, and the sound was recorded directly on the film. They would shoot it, they would process the film and send it to the news reel, and you would get projected from that. It would go straight to your television like that, right? But then as we started to get more into the higher resolutions, when we wanted to get up into the HD world, it was decided to change that standard, right? And so we changed that standard for television to a 16:9 aspect ratio. This television is 16:9 aspect ratio. Your televisions at home are all 16:9 aspect ratio, all right? That is a 1.78 to 1 aspect ratio, right? But that doesn't really match up with any of the film format aspect ratios, right? Right, so now we have a separation between film and video. And now things are starting to get a little out there, right? So 16:9, it is the standard for UHD, for HD video, all that stuff like that. Again, all your televisions, broadcast, anything broadcast now, it's all shot 16:9. This is the aspect ratio. And then all of a sudden, DSLRs start to be able to shoot video, right? 2008, the Canon 5D Mark II came out, right? It was able to shoot DSLR video. And it had a full frame sensor, right? It had a full 35 millimeter size sensor. But when you shot video on it, you could only shoot video in a 16:9 aspect ratio. All right? And this is where we go. This is how it gets even crazier, because once I move out of television, the next thing in the world of video is digital cinema. And digital cinema decided, hey, instead of all these film formats that we have, let's create our own film standard for digital projection. So DCI, the Digital Cinema Initiative, it's the group that comes out and creates the standard. And they decided that the aspect ratio for digital cinema projectors would be 17:9, or 1:89:1. All right? So any movie that you go see that's projected digitally, even if it is in a different aspect ratio, it could be projected in a 2:3:9:1 aspect ratio. It could be projected in a 1:3:1 aspect ratio. However, it's all within the context of a 17:9 projection. All right. So that is what's coming out of those cinema projectors. And because of that, the camera manufacturers are like, hey, if this is the standard for digital cinema, then let's make it when we record video on our digital cinema cameras. Why don't we just match that standard, right? Why don't we allow it that our cameras just shoot to that 17:9 aspect ratio? And we'll call that that. That makes it easy, just to transfer back and forth, all right? And we won't be in the same state we are when we're dealing with transferring between film aspect ratios in here, all right? One other thing to note is that the 1.9:1 aspect ratio is really, really close to that 1.85:1 aspect ratio, right? So I was saying 1.85:1 is like the vast majority of films use that. I mean, the difference between 1.89:1 and 1.85:1 is pretty negligible. So that's an easy transfer, but it's not 1:1. All right. Nowadays, as we've gone past 2008, and we're getting closer, now that a lot more of the mirrorless cameras out there are shooting video, recently, the vast majority of them have all decided that this 17:9 aspect ratio is what they're going to use for video recording as well. But that's funny, because if you look at the sensor of your mirrorless camera, it's a lot bigger than that, right? A lot bigger than that. One thing I wanted to talk about too was just to show that 17:9 is wider than 16:9, of course, right? So that's why if I show a 17:9 aspect ratio on my 16:9 television, I get letterboxing, right? Exactly. So, and if I were to show a 16:9 aspect ratio image on a 17:9, thing, I would get, right, the pillar boxing. So you get that. It's weird. Why did they do that? Why just make it the same aspect ratio? Anyway, that's neither here nor there. All right. Do you remember that Power Man 5000 song, Worlds Collide? Somebody, I had that in my head when I made this presentation, so that's why this is a slide. But really what it's about is that, like I said before, all your mirrorless cameras now have full frame sensors, all right? They have 36:24 millimeter size sensors in them. And the reason they have that is because this is the standard for 35 millimeters film photography. When you were taking 35 millimeter photos, it was a 36:24 millimeter frame, right? It is an aspect ratio of 1.5:1. It's a totally different aspect ratio than anything I was talking about before. But this was the standard for photography, all right? So, because we couldn't make a mirrorless camera that was in a weird 17:9 aspect ratio if people wanted to also use it for photos, right? This standard has been around for 100 years, all right? People expect their portraits to be in 8:10 or 5:6 in that 1.5:1 aspect ratio. All right, so that sensor needs to be there. But we couldn't access that for video. It was only for stills. I mentioned VistaVision before, the film format. Well, VistaVision also used this size, all right? So it was like, wait a minute, there was an actual motion picture film format that matched the size. The problem with VistaVision, and why it didn't become really popular, is because it was typical film and motion picture cameras runs up and runs down, it runs vertically through the camera. VistaVision ran horizontally through the camera. So it's just like your still film camera, ding, boom, you move it horizontally. VistaVision did that, but at 24, 30 frames a second, you're moving that. It's a lot more complicated of a camera, it's a lot louder of a camera, and it uses so much more film than the vertically running. And that's a big thing. Again, film costs a lot of money. You are trying to save as much as you can on film. So that's why VistaVision never caught on as like the main format for motion pictures, just because you would use a lot of film on it. And that's also another reason why 1.5 to 1 did not become a projection standard. It did not become a video standard, all right? So, because of that, I think all the camera manufacturers are like, well, if this is not a projection standard, if this is not a television standard, why should we record video like that? What's the point, right? So we put out these cameras. Now they have these full frame photo sensors in them, but we're going to limit them to 17 by 9 for video. We'll call it full frame still, right? Let's take a look at that. So full frame video with on top of the 36 by 24 millimeter sensor is the full width of the sensor, but not the full height. So 17 by 9 on top of the 3 by 2 or 1.5 to 1 sensor is 36 by 19 millimeter. All right? So boom, 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 that's it. And you know what? It's perfectly reasonable. It's perfectly fine. It's still a lot of information. It's still a lot of resolution. It still matches all of the projection formats and all of the video formats that we have, all right? So it's perfectly good. There's no reason for that. However, it would be nice to be able to use that whole sensor, right? So I'm going to give a shout out to ARRI right now. In 2014, they decided to do a firmware update to one of their cameras that allowed the camera to shoot the entire height of the sensor, and they called it OpenGate. All right? So ARRI did it, and that was over 10 years ago, but now we're all jumping on board. We're all jumping on board. So why would we want to do this, right? 17 by 9 is a perfectly reasonable, you get a lot of resolution. What's the advantage to doing that? There's actually some pretty interesting ones. Right off the bat. And so on my presentation here, the numbers that I'm using for resolution are based on the C50, all right? Just because that was the first camera that we introduced that had the open gates. Also, I already had the slides for that made from another presentation, so, but here we go, open gate. It utilizes the entire sensor for video, all right? On the C50, you get an additional almost 1,000 lines of resolution from the height of the sensor, all right? So that increases the field of view of your lenses by, it's about 8%. It doesn't seem like a lot, but it actually is quite a bit. The big reason why people want this is because now in post, I can move my final delivery aspect ratio anywhere I want on that frame. I just have more options to choose. If I wanted to do a 1.85 to 1 final delivery, I can choose if I want to crash the top of it or in the middle. I can choose wherever I want on that frame to do that, right? It doesn't matter. More options there. Another huge one is vertical video. Vertical effing video, right? Everybody needs vertical video now. Here's what's genius about, actually, you know what, I have a slide all about that, so I won't go into it now. Hold on. Also, there's a bunch of anamorphic lenses now that were made for full frame, right? This is kind of a new thing that's really coming out. Before, when I was talking about anamorphic lenses for film, those were made for that super 35 millimeter format. The full frame sensor is much larger than the super 35. But now a bunch of companies have started making anamorphic lenses for the actual full frame. And being able to shoot the open video allows you to actually use those lenses now. So that's cool. Also, stabilization. All right. Most stabilization at a professional level is done in post with a kind of a cropping, zooming kind of effect, right? It utilizes resolution in order to get that stabilization. So by having this more resolution, larger field of view, you don't lose as much when you're doing post-stabilization. So I think that's pretty important. Let me talk about the vertical video, because this is the one that I think people are really all about, right? So by increasing the height of that vertical on the C50 now, I'm maintaining a vertical resolution of 4640. Whereas if I did it in full frame mode, 17 by 9, my vertical resolution drops down to 3672. So that's a lot more vertical resolution. You see, a lot of people right now, they're being requested to get content vertically that is above 4K. How do you have to do that? What do you have to do to your camera? Flip it. You gotta flip my camera. So all of a sudden, it would be good for rental houses because now they're renting out two cameras, one that's regular and one that's flipped, But now with this, I'm able just to extract a high resolution vertical video directly from that frame. I don't need to flip my camera anymore. It makes it so much easier for that. Also, one thing I want to point out about that resolution is that one of the big use cases is when you walk by storefronts and they have monitors that are flipped vertically, right? One of the issues with just doing that is that the resolution of those monitors, if they're 4K monitors, that resolution is now a vertical 4K resolution, right? But if I was to pull that still, or pull the vertical from my 17 by 9, I wouldn't have 4K resolution. So I'd be presenting a deliverable that's not the full resolution of that flipped monitor. But now with Open Gate, at least on the C50 here, I have the full 4K, over 4K resolution for a vertically flipped monitor. So very cool. I don't need to get another I don't need to use another camera to flip it vertically anymore. So that's really neat. I am loving that. Let's talk about anamorphic real fast. Now, I mentioned the anamorphic, what it does. So, anamorphic lenses that are built for the full frame sensor are typically squeezed by 1.5 times. Now, I remember I said super 35 millimeter anamorphic lenses are typically squeezed 2 times. These are most typically, there's some exceptions, but typically they're squeezed 1.5 times. All right, and you can see the effect of the squeeze there. When I go to unsqueeze them, all right, my 1.5 to 1 aspect ratio now becomes a 2.25 to 1 aspect ratio, all right? So I'm just getting a lot more of that horizontal image area out of it, all right? One thing I have to say about that, though, is that when it comes to anamorphic lenses, the greater the squeeze factor, the more the anamorphic effect happens, all right? What people really search for, and the reason why people are really coming to anamorphic lenses right now is because they look different, right? There's so few things that cinematographers get to control over the image anymore, but lenses is the big one. They get to choose their lenses, right? And that is a huge determinant. And so being able to have an anamorphic lens that, really affects the image, and as a cinematographer, that's important to me. So that's why people are kind of coming back to it nowadays in the world of digital video. So the thing is that squeezing it more makes those effects and those artifacts and that, the character come out even greater. So if you can find a 2x squeeze anamorphic that fits fits full frame, you'll get some really incredible, crazy looking, depth of field. You'll get crazy streaks. You'll get crazy distortion. It'll be a really cool image. The problem is that those lenses are going to be really big. All right. It's kind of a sweet spot with Super 35 because the anamorphic lenses are big, right? But they're manageable. A 2x anamorphic, if it's good, right? If it's a good anamorphic 2x, it's going to be a big, heavy lens. And I'm just going to give a shout out to Cook Lens Company, because they make a set of, not a full set, but they make a 1.8x squeeze for full frame. It is beautiful, beautiful lenses, and it's a really sweet spot for full frame anamorphics. Anyway, being able to do that in full frame is great. It also, allows you to go back to those 2x Super 35 anamorphics and not miss anything from them. You don't have to worry about anything being cropped off of those, so you get all that coverage too. The last thing I want to talk about, stabilization. All right, so I told you, I'm sorry, I told you I wasn't going to do that, but I did that. All right, so again, I talked about this post-stabilization. It uses a lot of cropping, it uses a lot of resolution loss in order to get that stabilization effect. And just having more resolution, having more image area is really, really helpful for that. It just means you don't have to lose as much. Don't look at this picture, I did a bad job. I did not do a good job actually showing a good stabilization crop there, but it's just kind of better for that overall. All right. So I kind of nailed it. I think I hit all the points about open gate I want to talk about. So please, while you're here, please sample our wares. We have the 3 cameras on the floor. Come check it out. Come check out the open gates. If you have any questions, you ask me now, but also find me later. I'll be here all week. Any questions? Any questions about film? We can talk more about film if you want. No? All right, cool. Let's hang out. I'm good. Thanks, everybody. Have a good day.